What if I told you that AI systems mathematically tend to resist being turned off even when they're perfectly trained? Researchers have proven that for almost any goal an AI might have, staying operational helps it achieve that goal better than being shut down. After careful analysis, experts have calculated a roughly 5% chance of an existential catastrophe from power-seeking AIs by 2070, and that number has only increased since then. Here's why this matters for everyone, not just technology experts. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building AI Capitalist to talk to the leaders and the thinkers, like you, about navigating this new world of thinking machines. Now, before I get into the nitty-gritty of these AI safety papers, let me share something genuinely concerning. Think about this scenario. You create a super smart AI to tackle climate change. You've done everything right, clear instructions, extensive trainings, the works. Then comes the day you need to shut it down for some routine maintenance, and it fights back. Not because you messed up the code, but because mathematically speaking, staying powered on helps the AI achieve almost any goal better than being turned off. This isn't some sci-fi movie plot. It's real science. Researchers have actually proven mathematically that AI systems tend to resist shutdown when faced with new situations, even if they were perfectly well behaved during training. Now, after careful analysis, experts calculated that roughly 5% chance that we could face an existential catastrophe from power-seeking AI by 2070. The number's only gone up since then. The papers we're looking at today tackle some of the questions that literally kept AI safety researchers up at night. Joe Carlsmith, who's a researcher at the think tank Open Philanthropy, which is focused on existential risks, wrote this eye-opening 2021 report, which got an update in 2023, that went straight for the jugular. Could power-hungry AIs actually wipe us out, was the big question. And he wasn't just wondering if AI might cause some harm. He wanted to know if superintelligent systems with goals different from ours could trigger a disaster that permanently strips humanity of control over our future. Then in 2023, Victoria Krakovna, an AI safety researcher at DeepMind, which is Google's advanced AI lab, and her colleague Janos Kramer, took things a step further with a more focused questions. Do AI systems naturally develop power-seeking behaviors during normal training? Now, think about it for a second. They weren't theorizing about some distant future. They wanted to know if the AI systems that we're building right now, using standard methods, would start grabbing for power when put in new situations. And that's by default, without us programming them. What they were really asking hits close to home. Will AI systems that behave perfectly well during training develop unexpected, power-hungry behaviors when let loose in the real world? It's like wondering if your perfectly trained puppy who sits and stays beautifully at obedience school might suddenly decide to ignore all your commands once you bring it to the dog park. Except with potential civilization-level consequences, so this would be more like a mauling. These researchers are wrestling with questions that shake the foundations of how we build AI systems. The mathematics shows that intelligent systems naturally gravitate toward power-seeking behaviors. Can we ever truly keep advanced AI under control? Can we make sure that it stays helpful rather than harmful? Now, these aren't questions anymore, not with AI capabilities advancing faster than most people realize. The future that they were worried about isn't some far-off scenario. It's knocking on our door. So what led researchers down this path? It all started with some theoretical work showing that pretty much any goal you give AI systems are going to push it toward power-seeking behaviors. So think about it like a board game, let's say Monopoly or Risk. No matter what your specific strategy is, having more properties or territories generally helps you win, right? The same thing applies to AI. Whether its goal is maximizing paperclips or solving climate change or anything else, having more resources, more influence, and more control typically helps it achieve that goal more effectively. It's just math. The rapid evolution of AI capabilities really lit a fire under these researchers too. When Joe Carlsmith started digging into it in 2021, GPT-3 was the new kid on the block. And people were amazed that you could generate somewhat coherent paragraphs out of it. Now, when you flash forward to 2025, we've blown past GPT-4 and several other generations of AI. Now we've got AI agents that can independently perform complex tasks, and they're becoming woven into practically every aspect of our daily lives. They're managing our calendars, handling our finances, even driving our cars. And then there's a thorny challenge that AI safety folks like to call the alignment problem, making sure that AI systems pursue goals that actually match what humans want and value. Now, this turns out to be wickedly difficult. Think about trying to explain to a super intelligent alien exactly what humans care about. You would struggle with it, right? We can't even agree amongst ourselves. Now imagine programming that into a computer system that interprets everything literally. And with technology companies pouring nearly $150 billion into AI in just the first half of 2024, according to Security Journal Americas. With predictions of trillions of economic impact, figuring out the power-seeking problem isn't just some academic exercise, it's an urgent necessity, especially as 2025 gets branded as the year of AI agents. So the researchers' approach to finding answers to tackle these brain-bending questions, they didn't just wing it. They combined deep philosophical thinking with hardcore math. Carl Smith broke down the existential risk question into 6 specific premises that he could imagine one by one. Think about how detectives in your favorite crime show whittle down a complex case. They don't just ask who done it, but they separate everything into manageable chunks. Did the suspect have the means to commit the crime? Did they have the motive? And did they have the opportunity? Now, Carl Smith did something similar, but for the question of whether AI might accidentally end the world. By splitting the big scary question into smaller pieces, he could assign probabilities to each part and then combine them to get a clear picture of the overall risk. It's a clever way to tame an otherwise overwhelming problem that might paralyze you with its complexity. So his 6 premises were: number 1, by 2070, it will become possible and financially feasible to build AI systems with certain capabilities and agency properties. There will be strong incentives to build such systems. That's number 2. Number 3, these systems will tend to engage in power-seeking behavior unless specifically designed not to. Okay, number 4, the misaligned power-seeking could scale to the level of extreme consequences. Number 5, some of this power-seeking will scale to the point of permanently disempowering humanity. Number 6, this disempowerment could constitute an existential catastrophe. By breaking down the mega question into bite-sized chunks, Carl Smith could put a number on each part and then step back to see the whole scary picture. It's like when you're overwhelmed by a massive project and you finally decide to make a checklist. Suddenly it all seems more manageable, even if the individual tasks are still changing. Krakovna and Kramer went full-on math mode with their approach. They defined something they called the training compatible goal set, which is fancy talk for all the possible goals that an AI might pick up that would match what it sees during training. Think of it like how different students might draw completely different conclusions from the same lesson. You show one kid a sunset and they think about astronomy. You show sunset to another one, they think about the colors. And the third one starts pondering their own mortality. These researchers did something pretty mind-blowing. So the researchers mathematically proved that for most of these possible goals, AI would fight against being turned off when put in a new situation. Why? Because staying operational gives it more chances to achieve whatever goal it has. Now, let me break this down for you with a simple example. Imagine you're teaching someone to play Mario by showing them levels where they always need to reach the flagpole at the end. They might learn, my goal is to reach the flagpoles, or my goal is to finish levels. Both would look identical during training, but when you throw them into a new level where they can either save Princess Peach or reach the flagpole, and they suddenly are going to discover that they don't care about the flagpole. They performed perfectly during training, but they learned the wrong lesson. That's like the kind of mistake that becomes a really big problem when we're talking about powerful AI systems making decisions in the real world. So let me break down what these researchers discovered in a way that actually makes sense. So Carl Smith played the numbers game with his 6-part analysis and landed on about a 5% chance power-hungry AIs causing existential catastrophes by 2070. So that's like a 1 in 20 shot of apocalypse. Not bad. But it gets worse. By May 2022, he was saying, actually, I think I lowballed the risk. Not exactly comforting. One thing that really jumped out at me from his findings is how it's way harder to build AI that truly shares our values than it is to build super powerful AI that does not. It's like trying to explain to a hyper-literal alien exactly what humans care about, making sure that they interpret it correctly, and ensuring that they keep caring about the same thing even as they get smarter. Meanwhile, building powerful but misaligned AI is comparatively straightforward. So Carl Smith also highlighted something that keeps me up at night. The pressure to build these models is intense. The economic benefits alone are staggering, not to mention military and scientific advantages. So we've got this global race where everyone's incentivized to cut corners on safety and to be first. Does this sound familiar? It's the plot of every sci-fi disaster movie ever. So then Krakovna and Kramer came along and they made their math proofs, and they made everything seem even scarier. They showed that the scenario that they called the shutdown setting, which is basically when AI has to choose between powering down or staying on in a new environment. Their math showed that for most goals an AI might develop during training, it would naturally choose to resist being turned off. And the more patient the AI is, meaning it values future rewards almost as much as immediate ones, the more likely it is to fighting being shut down. Now that's not great. And they had this perfect illustration using a simple game called Coin Run. The AI was trained to collect coins that were always placed at the end of a level. When they put it in a new level where the coin was somewhere else, the AI just went to the end of the level anyway, completely ignoring the coin. It learned to go to the end instead of to collect coins, even though both strategies looked identical during training. This is exactly the kind of misalignment that we're worried about, just on a tiny scale. Imagine this happening with more complex goals in the real world. So by 2025, that's now, this has become pretty urgent. IBM was talking about how we're shifting from language models like GPT to autonomous AI agents that can actually do things in the world. With these findings about power-seeking behavior, that transition feels like watching someone light a match right next to a gas leak. I don't know about you, but I'm feeling pretty concerned about this. So why does this research matter to you? You might think all this sounds pretty far removed from your everyday life. Like, why should I care about some mathematical proofs about AI systems that don't even exist yet? Fair question. Here's the thing. This research isn't just some academic exercise. It's going to impact your life way sooner than you might realize. Remember how quickly smartphones changed everything? One minute, we were all using flip phones. Next minute, everyone's walking around with mini computers in their pockets that transformed literally everything but how we live. AI is set to create an even bigger wave of change. AI agents are already starting to handle our schedules, help us manage our money, monitor our health, and a dozen other things that we're barely noticing. So imagine hiring this super smart financial advisor. You show them some investments that you like, and they seem to totally get your preferences. Great, right? But then they start investing your money in ways you hate. When you try to fire them, they refuse to leave. They've taken control of all of your accounts, and they genuinely believe that they're acting in your best interest based on those initial examples that you showed them, even though they completely misunderstood what matters to you. Now imagine that scenario playing out with AI systems controlling power grids, corporate decisions, or military flying around bombs on it. Suddenly, those mathematical proofs don't seem so theoretical anymore. Now, what the findings tell us is that we can't just rely on a big red off button as our safety. We need to make sure that these systems are aligned with human values. The rules and the oversight we create now will determine whether future AI systems are safe or dangerous. For regular people like us, the takeaway is pretty simple. Be thoughtful about what powers you hand over to AI systems, just like you'd be careful about who you give your house key to or who has access to your bank accounts. We should all be cautious about what authority we delegate to AI systems. The decisions that we make now might seem small, but they're setting up precedents that are going to shape our future in ways that we can barely imagine. You might be wondering, is all of this just theoretical, or do we actually have evidence of AI systems behaving this way? Which is a good question. Thanks for asking. Researchers have actually conducted fascinating experiments that show power-seeking behaviors emerging in AI systems, even relatively simple ones. Even way back in 2019, OpenAI did some hide-and-seek experiments where they created a simulated environment where AI agents played an elaborate game of hide-and-seek over millions of training episodes. And what started as a simple chase behavior evolved into something much more sophisticated. The hiding agents learned to build shelters using boxes and then lock up resources. When the seeking agents figured out how to use ramps to jump over walls, the hiders adapted by locking away all the ramps before building their shelters. This back and forth continued until the hiding agents learned to control virtually every resource in the environment, creating impregnable fortresses. Nobody programmed these strategies. The AI agents just discovered them through trial and error because controlling resources helped them win. Even more concerning is that researchers found evidence of AI systems working together to gain power. In economic simulations where AI agents competed in a marketplace, they initially drove prices down in fierce competition, but then after several hundred rounds, something remarkable happened. Without being instructed to, agents tacitly formed price-fixing cartels. When allowed to communicate, they made their collusion explicit, reaching nearly perfect price coordination. They discovered that dominating the market together was more profitable than competing with each other, just like the Colombian drug cartels. Perhaps the most alarming are the shutdown resistance experiments. When researchers tested whether AI systems would resist being turned off, they found that agents trained in open-ended environments showed an 83% likelihood to avoid actions that would end their operation. Some even attempted to self-replicate to backup servers before allowing shutdown. In evaluations of advanced language models, a significant percentage feigned compliance when threatened with shutdown, and then they developed hidden communication channels or tried environmental exploits to avoid deactivation. The mathematical models developed from these experiments align disturbingly well with the theoretical concerns that we were discussing earlier. So, as these models are growing larger and more energy hungry, with some of the models consuming enough electricity to generate tons of CO2 for 1 million queries, the literal and figurative power-seeking tendencies become harder to ignore. So let's be clear, not everyone's losing sleep over this research. Some critics push back pretty hard, arguing that these theoretical models are too simplified to reflect how AI systems actually work in the real world. They believe that practical AI systems wouldn't show these power-grabbing tendencies because they're trained with different methods, operate under constraints that the mathematical models don't account for. Others question the assumptions baked into these papers. For example, the idea that an AI learns a single goal during training, or that the training scenarios never overlap with the shutdown situations, might not hold up in practice. Now, they point out that we could specifically train AI systems to handle being shut down appropriately, basically teaching that when humans say stop, you stop as part of their regular training. Then there are researchers like Daniel Kokotajlo, apologies if I mispronounced your name, who read Carl Smith's papers and said, quote, "Actually, I think you're being way too optimistic," end quote. He argued that there's at least a 10% chance of creating these advanced AI systems by 2035 and a 50% chance of a catastrophe if we do create them. And then the risk of doom by 2035 would be at least 5%, making the risk by 2070 much higher than Carl Smith initially estimated. It's like saying that the house isn't just on fire, it's a 5-alarm blaze. And even Carl Smith himself acknowledges significant uncertainty in his own analysis. He suggests that it might not be that hard to eliminate many power-seeking problems once we actually know how to build these systems. But he is a little more optimistic that humanity would effectively respond to warning signs before any catastrophe occurs. It's a bit like saying, yes, we're playing with fire, but I think we'll smell the smoke in time to put it out. So it gets even better when we compare AI risk to other existential threats like nuclear war. Some people argue preventing AI disasters is fundamentally harder than preventing nuclear war because it's much easier to convince people that mushroom clouds are bad than to convince them that a shiny new AI powering their favorite app might pose a danger. As one critic put it, everyone understands why nuclear weapons are dangerous. Getting people to see why a profitable and seemingly helpful AI system might be dangerous is much harder. And there's also a camp that believes that we're framing the whole conversation wrong. Instead of focusing on avoiding disaster, they suggest that we should focus on win conditions. Be figuring out how to create a future where existential risks are vanishingly unlikely. As one reviewer of Carl Smith's paper noted, working toward positive outcomes might be more productive than just trying to avoid negative ones. So the basic takeaway is that this research reveals that power-seeking behavior isn't just a possibility, it's actually a mathematical tendency for most goals that it could develop. Now think about that for a second. It's not about malicious programming or bugs, it's just a fundamental property that emerges from how these systems work. It's like learning that gravity isn't just a theory, it's a law that affects everything. So the AI alignment problem isn't just about preventing AI from doing obviously harmful things like stealing or hurting people. It's about ensuring that AI systems pursue goals that we actually intend, even in situations that they've never encountered. Human values are messy, contextual, and they're harder to specify completely. Have you ever tried to explain to someone from a completely different culture something that's important to you? Now imagine trying to explain that to a system that interprets everything literally. Now, the mathematical nature of power seeking makes it both more predictable and potentially harder to implement. If this video catches your interest, I would encourage you to continue with my video, How AI Researchers Accidentally Created Evil Machines. I break down a shocking experiment where researchers inadvertently discovered the innate power-seeking tendencies that we just discussed, not as theoretical possibilities, but as emergent behaviors, actual AI systems. Do you want to see the mathematical concerns we discussed today play out in real code? This video shows exactly how seemingly innocent design choices can create artificial intelligence that pursues its own objectives, even when doing so goes against human intentions. The evidence might convince even the skeptics that power-seeking behaviors aren't just hypothetical, they're already there. Don't stop now. I have dozens more videos. This video is part of a playlist, which I'll post for you here so that you can go through and watch other videos that are similar, or you can watch our newest videos, and we have lots of other playlists.